Hello students, welcome you all for the fourth class of laws of motion. In the previous class we have studied about what we mean by linear momentum. What do you mean by linear momentum? Linear momentum is nothing but a product of mass and velocity. Usually linear momentum is denoted with the letter P. And also in the last class we have seen how to derive an expression for rate of change of linear momentum. Please go through it, it's very important. So in the expansion part of that, in today's class, we are going to discuss completely what we mean by Newton's second law of motion. What do you mean by Newton's second? Already we have seen Newton's first law of motion. Newton's first law of motion is also called as law of inertia. Means if a body is at rest, it will be continuing to be at rest. If a body is in motion, it will continue to be in motion unless an external unbalanced force is going to act on it. This is about Newton's first law of motion. So today let us discuss about Newton's second law of motion. Before going to the Newton's second law of motion, first let me give you two cases. See, always a prediction or an analogy before the definition is very important. Just if I define you, what do you mean by Newton's second law of motion, you won't understand anything. So first what I am taking an example to make you to understand why Newton's second law of motion is like that. Understand? So let us see about case 1. See, in the case 1, I have taken two tennis balls. Can you see? This is tennis ball 1 and this is tennis ball 2. I am pushing the both tennis balls in this case. See, if push means what? Push and pull both causes force. Force is nothing but push and pull. Here I am pushing ball A. Consider this is the ball A and this is the ball B. I am pushing both. But this tennis ball, the tennis ball A, I am pushing very gently. In the sense I am pushing very slowly. But what about the tennis ball B? The tennis ball B, I am pushing it hardly. So what is the objective? This is a very simple analogy. We have trained it, we have played with it even. So when a tennis ball is being chased, otherwise a cricketer is being played. You know, the batsman, if he hits slowly, what happens? He can take minimum 1 run. Right? If he hits very hardly, he may get 4 or 6. So what was the difference in both the cases? Let us see. See, when the tennis ball is pushed gently, a smaller acceleration is produced. Obviously, what do you mean by acceleration? Rate of change of velocity by time, no doubt. See, when we apply a small force, what happens? Think that there is a ball. So if you apply a force very gently, it will move here. The distance covered by it is also less. Why? Because the force given by it is very less. So a small acceleration. Here we can produce only how much? A small acceleration. But when you consider in this case, when you hit a tennis ball hardly, what happens? A large acceleration is produced. True, right? Yes, when you hit it or when you push it is very hard compared to this. Obviously, if this is a small acceleration is produced, when we compare this tennis ball B with tennis ball A, this is going to have what? Large acceleration. We have studied what we mean by acceleration, what we mean by force, what we mean by velocity, distance, displacement, everything in the case of motion in one dimension. Understand? So here I am not going to stress much on what we mean by acceleration and all. So by this two tennis balls, what did we understand? So when we push tennis ball very gently, only small acceleration is produced. When you push tennis ball very hardly, a large acceleration is produced when compared to the tough tennis ball A. You are understanding that? Similar way experiment has been done by Newton. So by this, Newton concluded see, actually Newton didn't do this experiment only. He done some other experiment of the same method. I have taken one experiment of my own. Understand? In this way itself, Newton also conducted some experiment. And what did he found out that Newton concluded by the ego experiment? Newton concluded by the ego experiment, that is, the acceleration, whatever we have, the acceleration produced produced in the bodies is directly proportional to force applied. Directly proportional to the force applied. This we can write mathematically as F directly proportional to A. Consider this to be equation 1. Understand that as I have written force directly proportional to A. What is F? F is force. What is A? A is acceleration. If both are directly proportional, what do you mean by that? If one thing increases, the other thing increases. If one thing reduces, other thing reduces. Now come back to the examples what I have taken. In the first case, the small acceleration. If the acceleration is small, obviously the force what you applied is also what? Small. Come to second case. Large acceleration. Means if the acceleration is more, obviously the force whatever you applied is also what? More. More the force, more the acceleration. Less the force, less the acceleration. This is what Newton is being concluded from this. This is the first part of Newton's second law of motion. We have to take even case 2. By joining both, we will find out what you mean by actually the Newton's second law of motion. I hope the first case we have been understood. From the first case, we found out that force is directly proportional to that of acceleration. Now, I am considering two cases. Case 2. In a case 2, one I have taken as football, the other one I have taken as tennis ball. Can you see that football of 10 kg, tennis ball of 5 kg? And you can see the differences by the size also. Now you are applying force on both tennis ball and both football. But what is the situation right now is, see, if you apply a force on football or tennis ball, for me, both the balls should have same acceleration in same time. How can you do that? Means whatever the force you are applying here, see, understand the situation. I have football and tennis ball. We are applying a force on both, right? When moving, when both balls are moving, it should both have same acceleration at same time. Means whatever the force you are applying, obviously you should apply more force on football and less force on tennis ball, right? Then they can have both same acceleration and same. If you apply same force, if you apply whatever different forces, what happens? Tennis ball will with some other acceleration, right? If you apply a same amount of force, what happens? Tennis ball move very fast, football will move very less. Understand? But what we should do? We should make both football and tennis ball should move with same acceleration in same time. Means we should apply greater force. We should apply greater force on football, and we should apply smaller force on tennis ball. Why do you think so? Why a greater force is needed on football and why it is less force needed in a tennis ball to make to both to move in a same acceleration in same time? Because the football's mass is more. The football's mass is 10 kg. Tennis ball's mass is 5 kg. So by this way, from this Newton concluded that Newton concluded. Again I am telling you, Newton didn't do the same experiment. He might have done in a different aspect. Understand? As overall, after this, we will conclude like that. Newton concluded that. What is Newton concluded is the force produced on that and the force applied on bodies, the force applied on the two different bodies. Right, here I am considering two different bodies. The force applied on two different bodies producing same acceleration, producing same acceleration producing same acceleration is directly proportional to mass of the directly proportional to the mass of the body. So this mathematically I can write as F is force is directly proportional to mass. Consider this is equation 2. See again I will explain. The force applied on two different bodies. Yes, force is being applied on one football and one tennis ball. Both are different bodies, producing same acceleration. But I am telling you, both are having same acceleration. So when you have same acceleration means obviously the force you apply on a football should be more than that of the force you are applying on tennis ball. Means same acceleration. Why? It is directly proportional to the mass of the body. It is directly proportional to what? Mass of the body. That is, force is directly proportional to mass. Means with increasing greater the force, greater the mass. See, mass is more for football. So force you need to apply is also what? More. Mass of the tennis ball is less. So the amount of force you need to apply on tennis ball is also what? Less. Understand? So this is what actually Newton has been concluded from these both cases. Later, he had to forward this into an expression called as what you mean by mathematical expression of Newton's second law of motion. That we will see now. Now, we will see what is the mathematical expression of Newton's second law of motion. So, for that, what did I take in case 1? In case 1, we have considered force is directly proportional to acceleration. Force is directly proportional. Force is directly proportional to acceleration. So, take that as equation number 3. Force is directly proportional to what? Acceleration. Consider equation 1. Next, what did I take? Force is directly proportional to mass. Force is directly proportional. Force is directly proportional to mass. So what I have? F is directly proportional to m. This is equation 2. Understand? Combine equation 1 and 2. When you combine equation 1 and 2. So when you combine equation 1 and 2, what do you have towards LHS? LHS and you have F itself. Therefore, F is directly proportional to mass and acceleration. I can take like this. But if I remove this proportionality and make it equality, when I change this proportionality to equality, see, this is called proportionality, this is called equality. When I remove this proportionality, I need to add one term of constant. Here I am taking k as a proportionality constant. Therefore, this becomes F is equals to kma. Here, k is a constant. Here, k is a constant. Understand? And the unit of force, the unit of force is chosen to be, unit of force is chosen to be 1. That is, so k is also will be 1, m is also 1, and e is also 1. We will choose the unit of force to be 1. So we can take k is also 1, m is also 1, and a is also 1. So when we take this, what happens to this expression is F is equals to m into A. That is F is equals to, otherwise you can write it as force is equals to mass into acceleration. Understand? So this is what Newton's second law of motion's mathematical expression. I hope you have understood. See, the basic for the Newton's second law of motion is this. That is, force is directly proportional to acceleration, force is directly proportional to mass. How did we come to know this? By taking two cases. From case 1, we took that what it is, same tennis balls we have taken. One tennis ball we have moved gently, one tennis ball hardly. When you move gently, less acceleration. When you move it very hardly, more acceleration. That is, with increasing acceleration, force increases, acceleration increases. If force decreases, acceleration decreases. That we came to know in the case 1. So that is what force is directly proportional to acceleration, equation 1. What about second case? I have taken one football and one tennis ball. So if both should have same acceleration, what should I do? I should apply more force on football, less force on tennis ball. By that, what did we understand? We understood that force is again directly proportional to mass. Means if force increases, mass also increases. Means mass on football is more, so the force also we need to apply more on football. Mass on tennis ball is less. Means the force what we apply on tennis ball is also less. That we have considered equation 2. Combining this both, we came to know that force is directly proportional to what? Mass and acceleration. So removing this proportionality to equality, I will write constant of proportionality K is m into A. So when we consider force to be 1, unit of force to be 1, then this K also will become 1. So when it becomes 1, it will get negligible. So the expression becomes F is equals to m into A. Therefore F is equals to m A. That is, force is equals to mass into acceleration. Understand? This is what you might have heard. F is equals to m A, F is equals to m A. How do we get F is equals to m into A? That is how? By this. That is what I explained in the case 1 and case 2. Understand? Now we will see few graphs regarding this. Then we have a node. Then SI unit and CGS unit of force. Then conclude this chapter. Now we will see how the graphs are being related. That is, how force and acceleration are related in graph. How does mass and force is related, and mass and acceleration is related through the graphs. See, first graph what I am plotting is force versus acceleration. Force I have taken in x-axis and acceleration in y-axis. How does force and acceleration are related in Newton's second law of motion? We already know that force is directly proportional to acceleration. Is not. So if force increases, what? Acceleration also increases. If force decreases, acceleration also decreases. So we can see here, with increasing force starts increasing this side. So acceleration is also what? Acceleration is also increasing. Understand? So already we know the expression F is equals to m into A. Here I am speaking about force and acceleration. Right? I am plotting a graph between force and acceleration. See here, what is the other term? Other term is mass. So we will take mass to be constant. So when force increases, acceleration also increases. When force decreases, when you come this side, see how it decreases. I tell you, force 5, 10, 15, 20, 25. This is how graph you plot. Force is increasing this side, so acceleration is increasing. Why? With increasing, both are directly proportional to each other. With decreasing force, acceleration also what? Decreases. Understand? This is how graphs are really important. Please work it out. Next I have variation of force and mass. Here again I have taken mass in x-axis and force in y-axis. How does force and mass is equal? In case you remember, mass of football and mass of tennis ball. Mass of football is more, mass of tennis ball is less. If mass is more, force is also more. If mass is less, force is also less. How does both relate? Force is directly proportional to mass. Understand? So with increasing mass, there is increasing force. Here why acceleration is constant? Because here I am taking force and mass. I am plotting graph of this mass and force. So what is the other term which has been constant? Here acceleration is constant. Why did acceleration constant? Remember in case 2, I told you both football and tennis ball should move with same acceleration. Same acceleration is constant. When you keep acceleration is constant, when mass is greater, force is also greater. Therefore, they both are directly proportional to each other. I hope you have understood this graph also. See, the last graph I have taken mass versus acceleration. How does mass versus acceleration is related? Mass and acceleration are related inversely proportional to each other. Inversely proportional to each other. How it is? See, with increase in mass, acceleration decreases. Understand? If decrease in mass, acceleration increases. So you can see the graph how it is. You can see the graph. It is keep on decreasing. With increase in mass, acceleration decreases. With decrease in mass, acceleration increases. If it has increased like this, then see. If it has increased like this, it is directly proportional. But how the graph looks? Graph looks like this. Means with increase in mass, acceleration is decreasing. Understand? With decrease in mass, acceleration is increasing. So they both are inversely proportional to each other. This is a very, very important one. So I hope you have understood the three graphs, that is F is directly proportional to A, F is directly proportional to M, and M is inversely proportional to A. That is mass is inversely proportional to acceleration. So now we have what we mean by SI in CGS unit of force. So by that Newton's second law of motion we can continue. We have what is the SI and CGS unit of force. Already we have studied such cases in the case of motion in one dimension. You know how to give the unit of SI and CGS. The same way we follow now. Like force law, just now we came to know the expression of force is mass into acceleration. Is it not? We derived according to Newton's second law, force will be equal to mass and acceleration. Now we have to give the units, right? So first let me give the First, let us write what is the units of mass and acceleration. What are the units of mass? You have studied in measurements and experimentation chapter completely. SI unit of mass is kg, right? This is SI. Then what about CGS? CGS unit of mass is gram. Acceleration. What is the SI unit of acceleration? Acceleration SI unit is meter per second square. This is SI. Then what about CGS? Centimeter per second. See, if you know mass and acceleration units, you can write the SI unit of force easily. Now, therefore, SI unit of force. SI unit of force is what it is? kg meter per second square. Or see, always we don't use this unit. Whenever you see force, you tell instead of kg per meter second, you can write even this unit. This is correct. This is the SI unit. Otherwise, we can call it as Newton. Newton is the SI unit of force. Understand? Otherwise, you can write kg meter per second square. Even this is correct. This kg meter per second square itself is called as what we mean by Newton. Understood how to take the SI unit? Now, what is the CGS unit of force? CGS unit of force. So, what are the CGS unit of mass I have taken? CGS unit of mass is gram. CGS unit of acceleration is centimeter per second square. Now, do we have any other name like Newton in the case of CGS? Yes. In the case of CGS, we can write it as what you mean by dyne. Understand? This is a new concept to you. So, SI unit of force is Newton, CGS unit of force is dyne. The same thing you study in your 11th class. Whenever you go to your first PU, the same thing comes. This is all basic what you have been studying now. Understand? So you can write even kg meter per second square for SI unit, gram centimeter per second square for CGS unit. Otherwise, directly you can write SI unit to be Newton, CGS unit to be dyne. I hope you have understood. Now, one more very works for you also. Give the relationship between, give the relationship, give the relationship between SI and CGS unit of force. SI and CGS unit of force. Or how they ask the question is, give the relationship between SI and CGS unit of force, or Newton and dyne. Newton and dyne. We have to give the relationship. We have to give the what is the relationship between Newton and dyne. The question is same. Sometimes they will twist the question. They will give you SI and CGS unit of force. SI unit of force is Newton, CGS unit of force is dyne. Sorry. See, capital N. When you are writing Newton, capital N you should not write. You should write it in small letter. Whenever you are denoting only, you will write it capital. Now, to give the relationship between them, first let me consider F is equals to M into A. Understand? What is force SI unit? Force SI unit is Newton. Force SI unit is Newton. What is the SI unit of mass? Mass is kg. Right? What is accelerations? Meter per second square. So consider 1 year, for example 1 kg. 1 meter per second square for 1 meter. So Newton is equals to 1 Newton is equals to. So when you convert kg to gram, 1 kg is how many grams? Because you are giving relationship between SI and CGS. So I am converting whatever here SI to CGS. 1 kg is how much? How many grams? It is 1000 grams into 1 meter is how many centimeter? 1 meter is 100 centimeter. 100 centimeter per second. Can you see here? Now, therefore we have 1 Newton is equals to 1000 into 100. How many? So, in a way of physics, if you write 1, 2, 3, 4, 5, there are how many zeros? 5 zeros. That I can write in exponent form 10 to the power of 5. Can I write 10 to the power of 5? Yes, I can write 10 to the power of 5 gram centimeter per second square. Gram centimeter per second square. Therefore, 1 Newton is equals to, see, gram per centimeter per second. Gram centimeter per second can also be written as what? Dyne. Therefore, 1 Newton is equals to 10 to the power of 5 dyne. This is the relationship between SI and CGS unit of force. How does SI and CGS? 1 Newton is equals to how many dynes? 10 to the power of 5 dynes. This is what you are going to derive in your plus 1. That is your 11th class. Understand? See, to that we need to know what it is. Force is mass into acceleration. Kg to gram, meter to centimeter we have converted. Then 1000 into 100 will give me 10 to the power of 5. 10 to the gram centimeter per second square is also known as what we mean by dyne. Therefore, what is the relationship? The relationship is 1 Newton is equals to always 10 to the power of 5. I hope you have understood. And one more thing, in your textbook itself they have given one more important question is define 1 Newton. Define 1 Newton, define 1 dyne. You have this to define. So in your textbook you go through this. It's very important to define. What do you mean by 1 Newton and 1 dyne? They have given in your textbook. Write those definitions. Understand? If you read that itself, you will understand what it is. So this NC was what we mean by Newton's second law of motion. I hope you have been followed up. Please be very carefully. Listen to the class twice, thrice. If still you have notes, please be free in the class. I am going very, very slowly. I am not making you to go very fast because understanding is very much important. Right? If you didn't understand any of those calculations or anything, please be free in the class. So in the next class, we will solve some of the numericals based on F is equals to ma. That is Newton's second law